Does life exist on other planets? This is a question that as a human race we've wondered for a while now, and we're getting a little bit closer to understanding whether or not that's the case. So on the right is a photograph of the Hubble Deep Field. This takes up an area of sky the same size as if you took a grain of sand off the floor and held it at arm's length. And in that tiny, tiny patch of sky, you can see that there are hundreds of galaxies. Each of those galaxies has billions of stars and planets. So surely, statistically, there's got to be somewhere out there that has the right ingredients and conditions for life to exist. So on Earth, we basically estimate that anything else that might have life like on Earth could need things like liquid water to exist. So a good place to start the search, narrowing down that planet, is basically by taking how far away the planet is from the star. And by doing that, if the planet is too close to the star, everything interesting might evaporate away. If the planet's far away from the star, it might be too cold for any interesting chemistry to happen. Therefore, there's this region in the middle that we think might have the right conditions suitable for life. Now, it gets a bit more complicated than that. That's a good place to begin the search, but what about what's happening in the atmosphere? There could be gases like carbon dioxide and methane that have a greenhouse warming effect. And that means the planet could be further away from the star than you'd think and still be warm enough to retain heat and have liquid water. Conversely, it could be really close to the star, but have reflective clouds. Now, the clouds on Earth reflect about 23% of the light that hits us from the sun. And actually, that has such a cooling effect on our climate that they've been proposed as a solution for climate change. But the clouds on these diverse, exotic worlds aren't made of water. There's a place with an iron cycle where it literally rains down molten iron. Some of the clouds are made of sapphires, rubies, and glass. So I work with a team of NASA scientists to model how these exotic chemicals would absorb and reflect light. And what I've found is even the shape of the particles in these clouds can have a huge impact on the climate. So if the shape of the particle is long and chain-like, these form the most absorptive types of clouds, whereas if they form compact, almost spherical shapes, then they're much, much less absorptive. And this in turn affects how much radiation from the star that planet can absorb, and it affects the temperature and whether or not we might have the right ingredients for life, like liquid water, on the surface. So it's in this way that the single shape of a particle inside a cloud could not only change the climate of a planet, but actually help us discover whether or not we are alone in the universe. Thank you very much.